Good morning, students. This is your first experiment as per MU curriculum. You have to determine mass per unit length of a given wire, measuring diameter of that wire through a screw gauge. You will use this screw gauge, and this is that rod or thin wire you have to use. You will write like this. This is an example for a sample purpose. This is the notebook of one of the previous students, and this figure you will draw here of screw gauge, and then you will start like this. You will write apparatus required, and you will write then formula used. Formula used is m equals to pi d square rho. M is mass per unit length, d is diameter of the wire which will be found by screw gauge, and rho is the density of the material of the wire, which is iron. So we will proceed like. You can write brief theory about measurement, and you can take all these detailed, that is theory and formula used, with the help of your lab manual also. Then we will start doing observations. First we will find the least count of the screw gauge. For that we require to measure pitch of the screw gauge. Now to find the pitch, we will rotate this circular scale on this horizontal scale. Total 5 rotations, and in the 5 rotation we can see as here total 2.5 distance is moved to complete upper half, and then one below one. So total 2.5 mm is moved on the horizontal scale. So we can write total distance moved on main scale, that is horizontal scale, is 2.5 mm, and number of rounds with rotation we made, that is 5. So the pitch divided by x over y, that is 2.5 mm divided by 5, which is 0.5 mm. There are total 50 divisions on the circular scale. You can see 45, after this 1 2 3 4 5, then 0. So there are total 50 divisions on this scale. The least count can be found by pitch divided by total number of divisions. So pitch is 0.5 divided by 50 divisions, so this is 0.01 mm. In this way you can find the least count of screw gauge. It's here for you. As you can see that when we have completely rotated this screw gauge, that is by complete giving this round, so you can see that its 0 is not coinciding with horizontal line. Its 0 is actually below the horizontal line. 2 extra divisions are coming. So this is what the 0 error in the instrument. As there were 2 divisions up, means this is a positive 0 error. So 2 division multiplied by 0.01 mm, that is least count, 0.02 mm is the value. Similarly, we have repeated this process in 2 more repeated observations. We found once 3 divisions and another times 2 divisions. The mean 0 error, which must be rounded to the second decimal place only, because the least count is up to second decimal. So this is 0.02 mm only. So final mean 0 correction, the last correction in every observation, or the average value or mean value of the diameter which we will find through the observation, will be minus 0.02 mm. This correction will be made before finalizing the reading. Now you can see that the rod is kept in the middle part of this jaw. So the rod is completely fixed, and the observation here, there are 20 divisions passed on circular scale, and on the horizontal scale total 4 divisions are passed from above. So the main scale reading here is 4.0 mm, and 20 divisions on the circular scale, which will gives you 20 into 0.01 mm, that is multiplied by least count 0.20 mm. So the total diameter in mm is found 4.0 mm in this particular observation. So we will take few more observations. So we have taken these 5 readings. In normal labs you are expected to take 10 readings, but for this explanation online we are giving you the 4 or 5 readings value. So the least count rounded off to the correct decimal place, the final mean diameter after taking the mean, rounded off to the correct decimal place, it is 4.20 mm. So this is your final reading, 4.20 mm measured diameter of this rod. Here is your rod, this one. So this is the value of the diameter of this rod. We had used this rod. So we found that the diameter is 4.20 mm. Now observed diameter will be corrected by proper zero error correction, which was negative zero error. So 4.20 mm minus 0.02 mm, so 4.18 mm or 4.18 into 10 power minus 3 meter. This is the correct value of the diameter which will be used in this formula. And the density of the iron for this iron of this rod, that is material of this rod, that is 7.8 into 10 to the power 3 kilogram per meter cube. Substituting these values in this formula, we finally found, after proper application of calculations, operations, that is mathematical operations, this is 0.108 kilogram per meter. This is our final result. Students, now you can see that we have found the result. So this result will be shown finally in your notebook, lab work notebook. The 0.01 kilogram per meter, that is the linear density of the rod per meter density of the rod. So precaution and sources of error you can found from your lab manual, and you can write down the precautions and sources of error from your lab manual. Thank you very much for giving time and understanding this, and this process will continue. In the next video we will show you how to find the material, that is density of the material of cylindrical cylinder. This is the cylinder. We will show it to you how to find the density of this cylindrical material with the help of this is vernier calipers. So use of vernier calipers will be shown to you in the next video. Thank you for joining today.